So a big part of what we're trying to do is simplify technology and make it easy. SwarmFarm robotics is a vision that we've taken from, I guess, a background in farming all the way through to an ag tech company, and we're one of the only companies in the world that's actually commercialising autonomous agriculture, and we're actually starting to deliver this technology to farmers in Australia now. I started SwarmFarm because everything we do in agriculture is limited by what we can hook on the back of a tractor or what we tip in a spray tank. And if it doesn't fit in either of those two paradigms, we don't do it out in the paddock. And SwarmFarm opens an entire new world of farming technology. In this latest iteration of our robots, I guess there's 18 months of development gone into them. Our robots are slightly more powerful. We now have 75 horsepower. We originally had 24. And we've ruggedised the whole design now, so they're far more capable than our early machines. It's hand over the key stage. We're actually delivering these robots and leaving them behind on farms, and farmers are now using it.
How you going? Scott from Macadamia Farm Management in Bundaberg. We've had Lima with us for around about 6 weeks. It's been good to have her on the ground commercially mowing. I guess we're covering more ground in something that can operate more hours in the day. It's fairly simple to operate, so it's allowing us to have more consistency in operation.
I guess, we really like to keep technology simple. We see robots being a simple technology that farmers can actually set up and maintain themselves, and not something that overwhelms farmers.
We're really proud of what we do at SwarmFarm. We're ag-tech based in the heart of agriculture. We're based here on farm because we were actually solving our problems. In what we do with broadacre farming, we're limited by the chemistry we're using, so we're getting resistance to weeds, and we're also compaction's becoming a big issue. But every other industry has its own challenges, and that's what robotics is about.
A great part of this job is the practical environment in which we are. We're in a very dynamic team that is able to change from one thing to the other depending on what's required from either a customer or what we identify as a problem. So we can be creative with the solutions that we come up with, and it's fantastic to be able to implement those solutions straight away, test it on a machine, on farm, in the real situation where it's going to be working.
We've worked really hard over the last 7 years, and it hasn't always been easy.
And we're at a really exciting phase. We're building a new on-farm office thanks to the support of the Queensland State Government. We've got a great team and we're rolling our robots out all over the country.
I've been asking for one of these autonomous machines for over 5 years. It's here, it's working, and we want number 2.
When farmers first see our technology, they might initially think that, it's too small, it's not what I've had before. And I think that's another exciting thing, is to see those cogs turning and see the farmers thinking about what they could be doing and what's next and what they can implement on this machine. What we're developing is a platform for agriculture. It's a new operating system for agriculture.
Where we've got to head in the future is we've got to get better bang for our buck. We've got to grow more tonnes to the hectare, and anything that we can use to make that work better. And I just think the autonomous vehicles are going to be a big part of that.
What it's doing is driving the next big thing in agriculture. It's about how do we grow better crops to feed the world, and how do we do it more sustainably.
So in 10 years' time, I see SwarmFarm operating in every agricultural industry.
A base robot really doesn't do that much. It's what you put on board. Each of our robots is set up for the particular customer and how they want to use it. For example, Juliet's set up for spot spraying. Lima was set up to work in macadamia nut orchards with mower decks, but it's going to have more exciting stuff later. Mike was set up to do flower counting and spraying in apple orchards. November was set up to do cotton, both planting and spraying. And Kilo's a bit of a ladies' man. He loves cutting someone else's grass, so we set him to a turf farm.
From my point of view is, some of the paddocks won't get mowed completely during the day because we've got too much on. You just can't physically get these guys around every single paddock. What Kilo brings to that, doesn't need to stop at 4 o'clock in the afternoon. If it finishes at 9 o'clock that night, that's okay. It's done the job.
I think that the take-up in not only the macadamia industry but in all tree crops is coming, because I guess my problems are the same as everyone else's.
I think we're going to need a hand from autonomous machines as well as the labour force we've already got, because things are going to be more intensive.
And the future of agriculture is going to be driven by this far more exciting stuff. It's not just about driving a tractor. It's actually about, technology and biology and how all that comes together to grow better crops. I've been farming here for about 18 years. During that time we've been quite progressive in our farming operations. I guess I got an inquiring mind and always thinking about what's next, and as our farming technology plateaued out, I looked around and said, you know what, everything we're doing here is limited by what we could hook on the back of a tractor or what we could tip in a spray tank. If it didn't fit into those two paradigms, it didn't happen in the paddock. If you look at what's the perfect way to grow a crop, is it actually with a large machine, or is it actually with something that's quite small, that can do things slower but more accurately? And robots offered that. Our robots are a platform to carry smart technology around fields.
What stands out for us is the software developers can put a new bit of software on a robot straight away, and within an hour of completing that software package, it can be out on a robot in a field in real life conditions. We're attracting the best and brightest people in their fields, so all the different engineers, and we're actually bringing them to Emerald, getting dirt on their boots and getting them out in the field.
Our guys, they're working on their robots, they're testing their software, and they sit on the veranda of their office and critique the technology they've just built. You can write all the code you want, you can test it in simulation, you can test it in a trial, but it's not till you put it in a paddock with dust, dirt, heat, wind, birds flying in front of it, all these different things that you really test it. And then take it commercially and actually going and spraying a paddock where you really test machinery properly.
We've seen a real reduction in our chemical usage with the use of the swarms, and this is opposed to a conventional farming system with our broadacre spraying units. We were able to put them in there and pick up the weeds that would normally be missed, and the swarms have been able to target these directly and put on higher amounts of chemical at a site-specific location. Ag has been crying out for a robotic solution for a long time now, and SwarmFarm are really able to hit that market and provide that for us. We probably don't even realise what we can get out of it at the moment.
There's robotics coming out of every university, but what we're doing is actually getting our guys out of the office and into the paddocks and making the real practice change. Everyone can drive up a row and make them turn at the end of the paddock, but it's actually making those practice and incremental changes, because every paddock's different, every farm, every industry has different challenges.
A huge advantage of having a robotic mower here on the turf farm just frees up skilled staff to go and do better things for us with customers and deliveries, rather than tying up a skilled staff member on a tractor. The key element to keep our product looking so good is the constant mowing. It is every 3 to 4 days here on the turf farm. The major comparisons we found between our normal practices and the SwarmFarm robot was the steadiness of an even cut. The robot would identify an obstacle and stop, where sometimes that doesn't happen and irrigation gets run over.
Frank Sestak, I'm Farm Development and Technical Services Manager for MSF Sugar. We grow about 600,000 tonne of cane annually across about 10,000 hectares, and we're Australia's largest cane grower. Where we see the future in robotics is being able to get our farm management more precise. Currently, some of the inefficiencies on weed control is across a large area we can't precisely target the weeds that we want to target. So we target the majority of the field for the small areas of the weeds we have in the field. But some of the environmental concerns is we are a coastal crop, which means we're also right next to the Great Barrier Reef. With more precise application, we'll be able to manage our inputs more precisely and protect our catchments better. I think there's a real desire in the industry to adopt new technology to remain sustainable in the industry, and we think that robotics will be the next big thing.
Agriculture really needs a revolution right now to do things more efficiently, to do it more sustainably, and to lift productivity for the next generation that's coming through, because there's going to be more and more demand on the resources we've got to feed the populations of the world. At the moment we're doing spot spraying, we're doing blanket spraying, and we're doing turf mowing. But a bit that really excites me is our technology is a platform to deploy new technology in a paddock. Technology that doesn't work on the back of a tractor. Technology that only works when it's autonomous, when it's slow moving and extremely accurate. It's that ecosystem of new technology that goes on board a robot that's really going to be truly revolutionary in agriculture. And that's SwarmFarm's place in the world.
G'day, I'm Will McCarthy. I'm the Chief Product Officer of SwarmFarm Robotics. I'm here today to talk about the work we're doing in apple orchards in the Batlow region.
Trees are a little bit like people. Some are fat, some are thin. Each year they're different, they have different volumes of flower on them. If we can get more consistency with our thinning regimes and we can target those trees with a heavy crop on them, then that's going to be a really fantastic thing for our operation.
We asked farmers what the biggest factor in their flower thinning decisions were. The answer that kept coming up was getting the timing of application right.
In the orcharding game, I suppose no two seasons are the same. You know, we've had years where flowering can be from pink to petal fall within 5 days. It can be up to three weeks in another season.
So what we're doing in horticulture is we're developing a system that as it drives down the orchard rows, it'll photograph each tree. We can process that data and then generate a flower stage map. Flower stage detection is a new concept that we've developed through the work here in the orchards, and it's really about targeting individual trees within your orchard at different times. Rather than trying to treat the whole block as one blanket application, variable timing is about targeting each individual tree, applying primary thinners at the right flowering growth stage.
So this technology allows us to really focus in on the stages and hit the target when we need to. It's invaluable. So I'm working to assist SwarmFarm in getting the ground counts to verify the information and going back to the cameras.
In this project, we're using a unique approach for detecting the stages of growth of the apple flowers on the tree. We're training an algorithm with data from the last year and linking that up with specific areas in the field, and that's allowing us to identify across stages as early as green tip right through to petal fall what stage each individual section of the tree is at. The work that we've been doing so far has shown absolutely amazing accuracy of what we've been expecting since the start of the season. We've been able to show precisely at what stage each section of the tree is at, and then aggregate that along a row and even across the entire block.
One of our large costs is hand thinning. If we can get our chemical program fine-tuned to such an extent that we don't have to hand thin, or we only have to do minor clearing up, then again that is going to be a huge benefit to the bottom line in our operation.
I believe that the systems that we're working on will make a difference for the farmers. They have many issues getting things such as labour in, and this would be really helpful in reducing the amount of labour that's required in the long run.
These technologies with the measurement of the volume of the flower on trees will assist us greatly with our thinning programs. It will assist us in having greater yield per tree. I think it's just a no-brainer really for the future and the management of our operation.
We're getting more confident with the technology that we've built. We've proven now that we can actually detect the flowering stages of a tree or single trees within an orchard block, and that's from green tip all the way through to petal fall. And this year we're going to extend that work into fruitlets, from early fruitlets all the way through to picking.
The variation in the block is one of our biggest killers, if you like, in terms of production. For Fuji, for instance, we can go from 60 tonne one year to 6 tonne the next. This technology will enable us to target the on-trees within the block to try and turn the variability around. There's definitely a benefit in the technology. You know, it's something that we haven't had before. At the moment, it's walking through the block and having a look at the trees, whereas this will tell you exactly what's going on at the different stages and the variation within the block. That's the biggest thing that we find value in, is picking up the variation and being able to deal with it.
This season is the 3rd year that we've been collecting data out in the orchards, and we've seen significant improvements in that time in terms of the accuracy of detection of flowers, and now moving on to detecting individual stages for the farmer. We've also been able to speed up the process from something that's able to run offline, taking many hours, to run very close to real time now, to give the farmers an on-the-spot idea of what's happening in their blocks. They can then take that information to go out with the variable rate spraying and the variable time of application sprayer to actually thin chemically in order to get their consistent performance of the trees.
So the flower stage maps developed by the program will allow us to get assistance from agronomists off-site. Like can't see any reason why they would need to attend if they can use the heat maps produced by the program.
This year is the first year we're going to be able to put those maps in front of growers at a rapid speed and help them make the decisions on the ground. So we're going to work with the agronomists who look after this block and also third-party agronomists from Shepparton who are also going to look over the data and provide their feedback on what they would do purely based on the maps that have been put in front of them without having their boots on the ground, without seeing the orchard. So it'll be quite interesting this year to see what those two correlate to be.
I see huge potential for the emerging technologies which are coming into agriculture and particularly in our case into intensive horticulture.
We're taking the time to understand the agronomy. This isn't technology for technology's sake, and that's why we're working with local growers and agronomists on the ground here, where we're actually doing manual counts of what's on the tree and correlating that with the algorithms we're building to prove that this technology will be useful in the hands of growers.
At the end of the day, it's going to give us greater productivity. It'll give us greater surety of the volume of product per tree and will enable us in the long run to potentially be a lot more profitable.